Here we're going to explain what we mean by a saturated solution and a supersaturated solution, and also how that saturation or solubility depends on temperature. So let's look at a container, say a beaker, and let's say we're at 30 degrees centigrade and we add some potassium nitrate. So we have solid particles, they dissolve, and if we add enough, we're going to end up with a saturated solution. So I've represented a saturated solution as though we have potassium nitrate in solution with water, and we have solid particles sitting on the bottom. So we've dissolved as much as possible to dissolve. Now, if we were to heat this solution, we could dissolve more. So let's look at what that might look like. And so what happens if we heat the solution, as we can see from this plot of the solubility, in this case, the plot's approximately for potassium nitrate, as a function of temperature. As we raise the temperature, we can dissolve more, so that now there's no solids sitting at the bottom. And depending on exactly what temperature we raise to, we're probably no longer saturated. So we're below saturation because you can see the solubility increases significantly with temperature. It's not true for all solids, but certainly for a lot of solids, solubility increases with temperature. And now, if we were to quickly cool this, we could create what's referred to as a supersaturation solution. So if we were to quickly cool, then the solution would look the same. So notice that we don't have solid particles on the bottom. We're not at equilibrium. This situation here was equilibrium. Here we're not at equilibrium. This is supersaturation. Indeed, if we wait long enough, we go back to equilibrium, but we can't predict how long that is, and we can maintain this supersaturation for some time depending on the condition. So on this chart, what we did was we started saturation at 30 degrees. We started here. We raised the temperature to here, where now we can dissolve a lot more. We're not necessarily at saturation at that temperature. We may only have this much dissolved, depending how much solid we had sitting at the bottom when we started. And now we cool it back down 30 degrees, but we keep this higher concentration. We're above saturation. This is our supersaturation condition. If we wait long enough, we'll go back to equilibrium and get solid precipitating out. So we should note in this plot of salt solubility that on the y-axis, it's a ratio. So at 30 degrees, if we read values off, we have 50 grams of potassium nitrate or 100 grams of water, which means if we wanted to calculate a mass fraction from this type of plot, and this is a typical plot, then 50 over 50 plus 100 gives a mass fraction of 0.33 for potassium nitrate. So this idea of saturation, remember, is the equilibrium condition. Supersaturation is not an equilibrium condition.